Hi there, I'm playing with junk again. Believe it or not, I have another medical kit here. This time it's more like rotary tools, like this one, or hole saws like this one. And I think these tools are so small and so nice, I have to show them you through the microscope. Okay, let's go for it. Well, here is my favorite tool of this set. It's the super coarse diamond grinder, and that's how it looks from near. You can see there are actually diamonds, chunks of diamonds, held by some liquefied metal. I think they dipped it in molten, I don't know if this is brass or something like that. And then while it is hot, they dipped it into the diamonds and they stuck into that when it got cold. Another here is that milling tool here. It's a egg-shaped grinder. Then we also have a diamond grinder, a fine one. The other one was a super coarse one. You can see much smaller diamonds. And of course that one with extra small diamonds. Or this one with no diamonds, just sharp edges, good steel. You can see how sharp it is. If I scrape my finger around over it, it already takes some flakes from my skin. Maybe you can see that. Maybe it doesn't work so well now when I want to show you, but I made it pretty dirty before that. Then we have that kind of drill here. It has a drill-like tip and it goes wider the further in you drill, so you can use that as a drill or as a milling bit. I don't know exactly what it does. And of course this interesting thing here, just like a saw that cuts a little piece of something, maybe bone. Yeah, I think this is used to cut holes into bones. It also works with wood, of course. Wood is a little bit softer than bone, or most woods. And yeah, let's try that. Okay, then that's my Dremel Clone. It's not an original, but it's as good as that one. Takes that. Start my power supply. Yes, I'm using my lab power supply for that because at the moment I don't have another one. Yeah, and it works. Yeah, okay. Seems to work. Yeah, I tried it before, I know. And that's what comes out here. A bit different kind of tool is this one. It consists of two parts. One slides into the other. And then if the inner part rotates, it opens and closes that hole here. And what it does, I will show you a little bit closer. Okay, that's the outer part, that's the inner part. And when you turn it, it looks like that. Now you already have an idea what it is good for. Let me put a piece of paper in that. Well, didn't work so well. Yeah, it just cuts a piece away. And if that rotates a little bit faster, you can nibble some stuff away. Maybe soft bones or whatever. Okay, that's it. A little scissor thing. And we also have some saw blades, super small saw blades, maybe 5-6 millimeters wide. And we also have larger saw blades with titanium coat. So the golden color here, that's a titanium coating or titanium oxide or what it is. It's super hard, makes the blade stay a little bit longer in if you work with it. And for all those who find this medical equipment is a little bit disgusting, because, well, if you imagine what they do with that in your body, and let's go to something more funny. Lasers, medical lasers. I found another strange medical tool here. It's called Uni Laser 2000. That tells you a little bit how old it may be. It has a couple of LEDs, some keys, buttons, and a sensor to measure the laser output in milliwatts. Unfortunately, I don't have the handpiece with the actual laser. This is only the power supply and control box. I searched the internet for this and I only found one for sale on eBay, I think. And there is no information about the company, no information about this device. As I said, it's already quite old. So let's have a look inside. But before we take it apart, we turn it on. There is a power receptacle on this side. And by the way, this is a Swiss power plug. It is not a Brazilian power plug, as someone suspected in the comments, because the Brazilian power plug is almost the same, but the earth pin is a little bit more centered. It's also a triangle, but a flatter one. So if you want to annoy something from Brasilia, you send him a Swiss power plug. He will try to get it into his socket, but it wouldn't fit, and maybe it will break his socket. Or vice versa. If you live in Brazil, please send me a Brazilian power plug and I can compare the two side by side. Okay, let's turn it on. And you see, almost nothing happens. We have a mains or charge LED. There is also a battery inside. You can use it as a mobile device. No, nothing happens. Why? Well, simple. There is a key lock. And there are the connections for the probe, the handheld laser device, remote interlock with just a jumper inside, very professional, and external frequency, don't know what that makes. And I do not have the key, of course, but I thought, why not take an old HP server key that looks about the right size, and you know what? It works. So that's the good thing with these key switches here. They don't have so many different switches, so if you have a couple of keys lying around, chance is relatively high that one of them fits. Okay, now we can adjust output level from 10% to 100. Yeah, and we have a timer from 10 seconds to infinity and beyond. No, jumps to 10 again. Okay, emission start stop. No. Yes. And I guess after 10 seconds it probably stops. Yes. How about 20 seconds? Nine, 10, 15, yeah, yes, maybe 22, I don't know. Okay, how about the power meter? Reads, well, more or less 0, and it only reads when I press the button. So is it sensitive to light? Yes, it reads 1.5 right now. And if I go back with my lamp here, we're going back to 0. So that power light meter seems to work. Well, that's a little bit boring, I know. Let's take it apart. And always unplug the mains. Okay, so 6 screws on each side, and it's starting to fall apart. So we can remove that part. The lower one, which has an earth connection, we don't need anymore because I don't want to use that again. At least not as what it is. And we have a main board with some funny features. So here there's the key switch. That's a nice one, probably. I can use that again, especially if I have a key that fits more or less. It's just plugged in, so no problem to remove that. Then we have a bracket, that's where the battery lies inside. The battery holder with holes for 3 potentiometers, light meter adjustment, light meter 0 adjustment, and warning sound adjustment. You can adjust the volume of the beeper. 6 volt, 3 amp hours. So tiny little battery here. Maybe a LED battery. We have a nice toroidal transformer, which is plugged into the port. And here we have quite an interesting contraption. Okay, it says primary 110, 220, so it has 2 windings on the primary that can be used parallel or serial. Serie, it's a German product as it looks. No, made in Denmark. Made in Denmark. Secondary 17.25 volt and 18.5 amp red and red. That's the 2 here. 2 reds. 2 red. 2 red. 2 red. Fuck you. 2 red. Okay. We have this thing here, which is a plug and another plug and 4 diodes in between. So they actually, it looks like they put the rectifier in form of discrete diodes between this interface connector. So it seems they simply have forgotten to install a rectifier on the PCB, or maybe they intended to use a DC power supply, an external, and someone told them that it's a better idea to use a transformer, but then you need a rectifier and of course a capacitor, which also looks like they added it well after the design of the PCB. That's an interesting feature. So to convert a DC power supply design into an AC power supply with an additional rectifier and a capacitor. I would say it could have been made a little bit more elegant, but yeah, it works. But we're talking about medical equipment. Well, by the way, this laser product, as I found out, is a so-called soft laser. And soft laser is something that gets my badge, my Play with Junk award for crazy electronics, or for strange electronics, would be maybe a little bit a better text here. Soft lasers, by the way, that's the type number, serial number stuff made for medical safety. Soft lasers are not scientifically proven to work. What they do is, if you have a problem, if you have, for example, pain in your fingers from arthritis or something like that, they shine bright red laser light on this, and they say it helps. It warms up the tissue a little bit. I mean, we are talking about milliwatts here. Some combine it with infrared LEDs or infrared whatever, and they also use it to treat tinnitus. When you have problems with your ears, they have a special probe that shines red laser light into your ear. Some people say it's working, but there is no scientific proof for that. So it's a little bit voodoo, a little bit mumbo jumbo, a little bit, I don't know. Interesting part here, they added some foil that looks like some office material here, a piece of plastic sheet. Yeah, it's a clear envelope sheet with some foam plastic here inside. They tacked it to the side panel here. Well, and what's under this office plastic filter thing? strange green component with some glassy component on top and with two wires, a black and a white one. And that green component looks pretty much like a capacitor. And if you look at it, it's not connected to anything. It's just on this pad here, soldered, no connection. So they're using this green capacitor simply to hold up, to make a distance to the board for this, tiny little solar cell here. That's what it is. It's a little short of a solar cell. Then they take that voltage, so the more light shines on that, the more voltage you get here. And you measure that voltage with these two interesting chips here, CA3161 and CA3162. Those two combined with this 7-segment LED displays and 3 drivers for each display, 1 driver transistor with a couple of external components. That's a voltmeter. That's a simple digital 2-chip, very old design, 92. I think you can still buy them, and with these two you can make yourself a 3-digit voltmeter. That's the beeper, buttons, LEDs. And from the date codes we can see it's all 89, 89, 91, 92, so they 88, so they have chips from 4 years. Maybe the production was not a high volume production, so they had a lot of chips in stock and they just took what they needed. Okay, it's all simple digital. It's counters that count up and down, decode that to the LEDs, and somehow make a clock that I think we don't even have a crystal, a quartz crystal, no. So the clock is more or less accurate, maybe plus minus a couple of seconds. Then we have power transistors here, so I assume that's for voltage regulation. We also have power transistors here. They are very close to the output, so I think they are here to regulate the laser. It's most likely a diode laser, so yeah, they just regulate the amount of current that goes through it. Then of course you can measure the effective output here, and yeah, that's it. Then you decide how long you want to beam that laser on the patient, and let's hope it works. Okay, thanks for watching.